Okay, hello everybody. Welcome to today's interest session. This is the first of the fall 2024 semester, September 26th. This is on designing networks with Cisco Packet Tracer. So interest is designed to, the program interest is designed to give you an introduction to all kinds of proprietary technologies that are most of them are careers in themselves, right? If you could just stay in that one area for the rest of your life, you'd have a great career. Not recommending that, but overall, we just try to pick technologies that there's a lot of opportunity for, a lot of jobs available, a lot of kind of steady hiring going on, and a lot of steady growth. And networking is one of those areas that is just that alone, without being a programmer, without being a database administrator, without being a AI expert and machine learning data scientist. Without any of that, just networking alone give you just an unbelievably successful career through your life. One of the ways to do that is to take some of the certifications that are available from Cisco, not to focus on one. There's Fortinet, there's all kinds of other creators and manufacturers of network technology, but Cisco provides something called Packet Tracer, which is a software designed to help you design and test your network designs first, but it's also a great educational tool. So today we're going to be creating peer-to-peer networks, local area networks, and wide area networks, all in the same session. You'll be able to kind of play back the video and try this yourself. And Cisco Packet Tracer is a free software. You do have to give them kind of some user information. But other than that, as soon as you download the application, you can start doing what I'm going to do for you today. So just to put this into perspective, into context before I start. So the concept of computer networking, whether you're aware of it or not, is the fact that there's a ton of equipment that makes it possible. Like we all go on our phones and we just kind of surf around and send text and all that stuff. But really, networking is what makes that happen. And all the equipment behind that is what makes that available. So from your phone or your tablet or anything like that, you're going from a wireless device to a wireless switch. But on the same note, we call them wireless access points or WAPs. But basically, that's wired down to switches and to routers and connecting networks to networks. And the biggest computer network of all in the world is the internet. And it's just a series of smaller networks all connected together through something we call a router. Now, making that all talk to each other is really what we're going to be talking about today. But as you can imagine, finding one person that actually knows how to do all that and fix your internal organization's communications from workstations to the servers, from the servers to the routers, and the routers to the firewall, right? So all these different knowledge-based items that you would need to learn to do that, a lifetime a lifetime of work awaits you, all in that single field, right? So that's, again, what interest is about. Interest is about introducing you to these technologies, teaching you a little bit about them and showing them how to get started, and then getting you to think about like, ooh, I kind of like this. Let me see how I can make a career out of it. And usually with these programs, we pick technologies that you can do that if you choose to, right, and not change. All right, so this is kind of what we're talking about today. Switches and hubs, and the hubs are really not used anymore, but the switches kind of took over for those. But multi-layer switches, firewalls, bridges, routers, repeaters, modems, all these different networking technologies and the wiring that makes it happen. We're going to show you how that all gets designed and how it works in a network design. And to do that, we're going to use Packet Tracer. So with that, I'll change over to the Packet Tracer software. Again, Packet Tracer software is just a like anything else, it's a particular piece of software that you would load. Like anything else, it's comes up and you can click on an icon and load it up and basically just run the software off of your machine, right? In this case, our training server here has an icon called Cisco Packet Tracer. It's an install that got done from the Cisco software, and that's basically what we're in. So nothing magic there. You do have to do the download, do the install, and then once you're on, basically everything I do from now on is you can do at home. So let's start off with the basics. Let's start off with a peer-to-peer network, which is two computers talking to each other through one cable. No network equipment at all, but just two network cards that in the computers plugged together through something we call Ethernet cable or Category 5 cable, right? Could be 5E, could be 6E. But basically, let's start with the basics. So what we're going to do is we're going to basically use our categories down here by going from network devices to end devices. And in end devices, we'll see that there's PCs and laptops and servers and so forth. So I'm going to connect two PCs together. I'm going to drag one PC up here, another PC up here, and I'm going to basically connect those two PCs together directly. And I'm going to choose my little lightning bolt here, which is cables. And these are the different types of cables that are available. Console cables, which you use to connect from your computer or your laptop to a new device that just got shipped to you, or something that you're reconfiguring. Connecting directly to a router, directly to a switch, directly to a firewall, and configuring it through your laptop. Straight through is what we usually use to connect from devices to a switch, which we're going to do next. In this case, we're going to use a crossover cable to get two devices to talk directly to each other. It's a software, it's a simulation, it works just like the real thing, but you could take two devices at home and do this, and it would work the same way. So I'm going to choose a crossover cable. I'm going to connect my fast Ethernet network card that's in the computer. I'm going to connect my other fast Ethernet card that's in the computer, right? And we're going to get a green light in this case because those cards automatically start talking to each other. We may get an orange light on the switch or even a red light on the router if it's not configured properly. So, so we're basically going to give these two computers, I'm going to use a little notepad here so we don't lose our way. I'm going to give it a 192.168.1.0 network addressing scheme. Now, in this case, 192.168.1.0 is called a Class C IP address. It's a 24-bit IP address, which means that each of 4 octets, 8, 8, 8, and 8, we're using the first 3 octets, 8, 8, and 8, which means 24 bits, either 8 bits apiece. So this 192.168.1 is called the network, and .0 is called the host because the first 3 we've identified as a network address, right? So we're going to make this 192.168.1.1 and 1.2. All right. Now we can use notes for that too. And we can make this 192.168.1.1, and we can make this 192.168.1.2. Now, that alone does not actually make the community. It's just a note. It's just a note to tell us what we want to make it. What we have to do is go into the computer itself. And the cool thing about Cisco Packet Tracer is that it will take the devices themselves and will allow you to go to the desktop of those devices. They're not real. It's a piece of software. It's simulated, but it actually lets you go in and really configure the IPs and communicate over, the command prompt and all that stuff. So it behaves just like a Windows PC. So I'm going to go to the IP configuration here, and I'm going to give it what we call an IPv4 address, Internet Protocol 4 address. And that's going to be 192.168.1.1. And we're going to use a subnet mask of 255.255.255.0, meaning that we're using a Class C addressing scheme, which is a 24-bit addressing scheme. Only the last octet is going to identify the machine that we're talking about. Now, on a network like this, we're just going to use .1 and .2. But if you think about that, that leaves only 253 more devices on this network because it's a Class C. Class Cs are private networks, which means you're not going to have a lot of devices. They're your home networks, your small office networks. We call them SOHO, small office home, small home networks. Small office, home office networks, SOHO. Okay, and we're not going to fill the default gateway yet because we don't really have a router in place. So we're just going to configure it this way. And what we're going to do is we're going to configure both networks to be, go to the desktop, go to IP config, and we're going to configure them to 192.168.1.1 and 1.2. And these particular IP addresses are going to now talk to each other. The way we test things in packet tracers, we're going to use this particular envelope here, which is the packet transfer. And we're going to send a packet from machine 1 to machine 2. And if we get successful, that means you've configured your network properly. If you want to see what happens when you configure a network wrong, if we say we gave this an IP address of 192.168.2.2, which is a completely different network, now when we send a packet, we're going to get fail, right? It's going to be in progress and fail. And if you want to see what that would really look like on a real machine, if we go into that machine and we go into the command prompt and we do ping, well, first of all, we could do IP config. That's the network command to actually find out the IP address of a machine that you're on. This will work on your home machine too. And if I go to ping 192.168.1.2, which is the other machine, I'll get failed, right? Because it's not working. So my envelope failed in packet tracer, but also the real experience you'll get is failed too. We call it request timed out. But if I go into my machine and I go to IP config, and I make that back to 1.1, 1.2 in this case, what's going to happen is when I go to this machine here, and I go to ping 192.168.1.2, I now get a reply, right? So a packet is a 32-byte packet, so it's actually sending 30-bit packet from one machine to another, and we're getting a reply back, right? So that is the basic of all basic computer networking. You configure 2 devices with a crossover cable. Now, a crossover cable is a special cable when you're not using a switch. Crossover cable switches 2 to 4 of the lines in a certain way so that the 2 network cards can talk directly to each other. The limit with a crossover cable is you can only have 2 devices talk to each other. You can't have 500 or 2 or 5 or 10 or 20 devices talk to each other on the same network. You can only have one machine talk to another machine. Now, it's extremely useful in doing computer backups when you don't have other networking equipment around, but it's not very common in a real office networking environment. But it's a great demonstration of networking in general. Now, let's take this in Packet Tracer. Let's take this network. Let's highlight it, and let's highlight it, and let's move it. Give me 1 second here. Let's move it up here. So that is our peer-to-peer network. Now we're going to create a local area network, a LAN, and we're going to use a switch to connect everything. So now we're going to go to our endpoint devices, and we're going to drag a PC, a laptop, and a server. And we're going to also need a piece of equipment to connect all of them. So we're going to go to network devices, and we're going to choose switches. And we're going to choose one of the model of switches that Cisco gives us. We're going to choose a 2960. Okay, and once we put the switch, machine up, the switch up there, now we can go to the wiring and we can choose straight through copper, which is essentially Ethernet cable, and as far as Packet Tracer is concerned. And what we're going to do is we're going to basically, just for you aware, depending on how many wires you hook together, there's 8 wires in Ethernet cable, and they're twisted around each other, 2 wires at a time, called twisted pair. So basically, if you hook up all 8 wires in a series in a row, that's a gigabit speed configuration, right? 1 gigabit per second, right? So basically, how you wire your cabling with, 4 wires or 2 wires or 8 wires changes the speed that wire is able to handle. So it's 10 base T, 100 base T, gigabit, all straight through copper cabling is gigabit wiring. So we're going to hook this particular computer to the network card. We're going to hook it to, say, I don't know, let's just hook it to port 2 in the switch. Doesn't really matter where you hook it as long as it's open. We're going to hook this laptop to port 4, and we're going to hook this laptop, this server, we're going to hook that to port 6. Now you'll see an orange light for a few seconds when it comes to the network design. That orange light is indicating that these machines are sending packets through TCP/IP, broadcast packets to the switch. The switch is reading them, and it's saying, "Hey, who are you? What is your MAC address?" A MAC address is a media access control identification. It's a hex identification, hex value that basically is burned into the communications card, the network card or the wireless card at the manufacturer. So we know when packets are collected off a network who's sending that based on the MAC address, right? That particular ID is being read by the switch and saying, great, MAC address 1, 2, or 3 is plugged into port 4, 5, or 6. And that's how the switch works. That's why it's orange for a while until it figures out who that is. So now what we're going to do is we're going to configure this particular network. We're going to configure it in a Class B configuration. We're going to use 172.16.0.0, and we're going to give this a 255.255.0.0 subnet mask, right? So this is considered a Class B. Class A gives you, Class C gives you 255 devices that can be 254, because one is used as the broadcast IP address. Devices on a single network. Class B will give you much more. I don't know the number off the top of my head, but it's many more devices that can be added to that, because we're using the last 2 octets. We're using 1.1, 2.1, 3.1, 4.1 in the octets. Okay, so we're going to basically configure this first PC. We're going to configure as 192.168. Excuse me, I'm sorry, we're doing a Class B. 172.16. I don't know, let's say .1.1, right? And that's automatically identifies as a Class B in the subnet mask, okay? And this one is the laptop is going to be configured as, don't forget, we can go to the desktop and go to IP address 2 and configure this. So it's going to be 172.16.1.2 and so forth. And our server is going to be configured as, excuse me, we're going to go to settings, sorry, to interface fast Ethernet, and we're going to make this 172.16.1.3. So we have 3 different IP addresses. You cannot have 2 IP addresses the same on the network. It's called an IP conflict. So that particular that issue happens quite often with static IP addressing, where you just configure something wrong and it doesn't work because it's got a conflict, and it'll tell you that there's another device on your network that has that. And if you notice, when we talk about MAC address, that's the MAC address of this particular network card on this particular device, right? So now we have 3 different devices that are connected to a switch on a Class B network, right? This is your typical local area network configuration. And if you go to the packet here and the envelope here in Packet Tracer, and you ping from one device to another, we should get successful because they're all communicating on the same subnet, which is 172.16.1. whatever or .1. Now, because it's Class B, we can have another device that's 172.16.2.1. It would still work. If you want to see how that works, what we can do is we can go to end devices. We can drop, say, another laptop over here, and we can go to the wiring and then connect that laptop to the switch and some other port that allows to connect. And what we can do is we can give this laptop, because it's a Class B network, we can use the last 2 octets. What we can do is we can configure this as 172.16.5.2. Doesn't really matter as long as we use the last 2 octets. But what that means is that network, that particular laptop, even though it's not 172.16.1.5 or 1. Whatever the next in line was, it doesn't matter because we're using the last 2 octets. So you can have a whole bunch of different devices on this network. And if we ping from that laptop to this laptop, we get successful just like the others because it's using the last 2 octets, which are identified as being able to be used by the subnet mask. So how you change the subnet mask is how allows you to use a bigger combination of IP addresses, right? Okay, now we're going to move this LAN over. I'm having trouble with selecting for some reason. I guess I got to select the bigger area. So now we have, right? Now we have a peer-to-peer network, local area network, or a LAN. Okay. And what we don't have yet is a wide area network, which is 2 LANs connected together by their routers. This LAN doesn't have a router yet. We didn't put on that. We don't need one because we're just talking to each other. As soon as we need to talk to another network somewhere else, we need a router, which is why you have a wireless router at home for Verizon or Optimum, because you're really talking to another network, which happens to be Verizon, happens to be Altice. I call it Optimum, but it's Altice is the company that runs it. You're connecting to their network, which means you need a router. So routers are used whenever you want to connect 2 local area networks together. Your local area network at home has a switch in that device. That router that you have, that's a Verizon router, also has a little switch in it, but they're 2 different technologies. The switch connects devices together on a local area network. The router connects that network to another network. Now, what I am going to do, so I don't lose my mind here, I'm going to save this, and we're going to save it as interest, demo. And this will save this as the diagram that I could open up at a later date and time and still function and operate. So you can, as you create your own diagrams, you can save them and kind of go back and forth, making changes to them and testing things, right? So now what we're going to do is we're going to give, and the files that Packet Tracer uses is called PKT files, .pkt. So that PKT file is something you can open up and use and look at the configurations and so forth. So now what we want to do is we want to create a wide area network, right? Which is also called a WAN. And with that, we have 2 LANs. We'll call this LAN 1 and we'll call this LAN 2. And we're going to connect those LANs. This is a wide, not wise. We're going to connect those LANs between their routers. Okay, and I'm going to show you how to do that in Packet Tracer as part of your exercise. All right. So to make things simple on ourselves, let's take LAN 1 and let's just copy it and paste it so we can have LAN 1 be kind of over here. Okay. And then let's copy and paste again and make this LAN 2. Right. That'll kind of shorten up the design time for creating this thing. By the way, I highlight and I select, I hit Control-C to copy and Control-V to paste, and it just makes a new segment on there. So right away, I've got this kind of cool little design we're working on here, but it's not really going to work the way we want it to because we want to use, different IP addressing schemes, and we want to use connect them to a router, which doesn't exist yet. All right, so we have to do a couple of different edits to make sure that we're in the process of doing that. Okay. So the first thing we want to do with this particular network is we want to change the IP addressing scheme so it's unique, so that we don't get confused in our design. So let's make this a class C, which is 192.168.1.0. Let's make it .10.0. Okay, and we'll make this a subnet mask of 255. And then let's make this also a class C, but let's make it 192.168.20.0. And let's also make that a 255. All right. And what we can do is we're going to connect our 10 network to our 20 network. But you have to remember, if you want to really try to visualize this, let's call this New York, and let's call this LA. And the reason I'm doing that is that you understand that wide area networks aren't networks you connect from your front to your kitchen to your bedroom. Wide area networks are geographically distant enough that local Ethernet cable does not work. 100 base T cable or straight through cable has a 300-foot, 100-meter limitation so that the signal doesn't transfer past that range reliably. So wide area networks come into play whenever you have a geographical distance of your two different networks where you have to incorporate the cabling on the telephone poles and fiber optic cabling and things like that. That just is going to have to carry your signals from your network to another. So it doesn't matter whether it's St. Louis to Kansas City or whether it's Miami to Boston. The wide area network configuration is the same no matter how you do, no matter what the distance is. Once it's a wide area network, it is a wide area network, and the same contents happen. So let's configure our network first. Let's make sure we configure all these devices to 192.168.10. So we're going to come in here. We're going to change our networks to 192.168.10.1, and we'll do 255.255.255.0 as a subnet. Okay. Let's change this one to 192.168.10.2, and we'll do 255.255.255.0. Okay. And I'm going to take the laptop out just so we don't have to do so many of them. It won't make a difference in our design. And I am going to name the server, though. I'm going to name that, I'm going to change the IP address to be 192.168.10.3. And that's going to be a 255.255.0. Okay, and if you want to do a quick test to make sure these things talk to each other, that's always useful and helpful, and it stops you from having any kind of communication issues in the future at later stages of your design. So now 20.1, we're going to go to fast Ethernet, and we're going to call this 192.168.20.1, and that's going to be a 255.255.255.0 class C 24-bit. And this is going to be the laptop, which is going to be the fast Ethernet. We're going to call this 192.168.20.2 and 255.255.255.0. And finally, our server on this network is going to be 192.168.20.3 and 255.255.255.0 on the subnet mask. And what we can do real quick is also just send a couple of different packets through this network and make sure they all talk to each other. And we get success on that one too, right? Now we save our design and now we have our network in place. Now, to send packets from one local area network to another local area network, we need a device called a router. And the router will use a number of different protocols to talk between routers. And that's why it's a special device. The routers have a protocol that they talk to each other with, but on the same note, they can also be on a network as another device. So the first thing we'll do is we'll go to our network devices here. And instead of clicking on switches this time, which we have in place already, we'll click on routers. And for this example, we're going to choose a 2911 router just because that model is easy to use and demo with. So I'm going to choose this particular model. I'm going to choose this particular model, and we're going to dump a router onto these networks. Now, routers are devices just like any other type of device that you put on a network. So they have a network card, right? And we're going to basically use this cabling. We're going to use straight through cabling, and we're going to connect the router on its gigabit network card, in this case, number 0. We're going to connect it to a certain port 8 on our switch. Now, network cards on routers are off by default. So what you have to do is you have to go into the network card itself, which is 0, and you need to turn it on. And then you also need to give it an address on your network. So in this case, it's going to be 192.168.10. We'll make it 100 so it's identifiable as the router. We'll make the two routers in this example 100. Right? And what we do in routers that's different than a workstation or a switch in Packet Tracer release is that we have to save the configurations whenever we make them. And what you'll see something called CLI or command line interface, which is here. Anything I'm doing through the Windows-based configuration for a Packet Tracer is also available in command line interface on the router itself. So once you connect to a real router, you can do command line interface commands to that. So you can practice with that as well. So now what I'm going to do is I'm going to connect the second router to the firewall, and I'm going to use the gigabit 0 card on that router, and I'm going to connect it to this particular switch. And then I'm going to go into the router, and I'm going to configure it for this network, where I'm going to go to the gigabit 0 network card. I'm going to turn it on, and I'm going to call it 192.168.20.100, right? So the 100s are your routers, but they're on two different networks, 10 and 20, 10.100 and 20.100. So they're in two different networks, all talking to each other. And now I'm going to save my particular card, and I'm also going to save in settings. I'm going to save it's called flashing the BIOS in the on the router. So basically, we're just saving that does that for us. Saves the configuration. So when router gets rebooted, which we will do in a second. Now, the next phase of a wide area network is to connect your routers together through whatever line, we'll call it, you're purchasing from your telecommunications vendor, right? If you're buying a T1 line, a T3 line, if you're buying an ISDN line, if you're using two internet-based routers from your service providers, right? Using VPN, but whatever that line is, we have a way to represent that line in Packet Tracer. And traditionally, what we've done, in the past, and for years and years and years, we've taken our routers and plugged them into what we call CSU, DSUs on our wall that go to kind of the phone lines and go out to anywhere in the world through those lines, through the switching that the phone company does. And we'll use that example today. So we're going to use something called serial cable, a DTE cable, to connect these two routers to the telephone poles system that we'll just kind of talk about. We'll refer to it as that for this demo. So we're going to connect these two routers directly to a simulated telephone network that we would use, internet network that we would use to connect them to. And to do that, we need kind of some special devices to connect that. Now, you can connect two routers using Ethernet cable. You can connect two routers using fiber optic cable. That's true, and you can do that. But it's because they're geographically distant, you're almost always connecting them to some existing network, which is your phone service. So what we're going to do to simulate that is we're going to basically connect them with serial connectors. So what we're going to do is go into router 1, and what we're going to do is we're going to turn the router off. We're going to turn this switch off and turn the power off. We're going to bring over this particular device, this hardware component. That's a serial high-speed WAN interface card, right? It's not default in the router, so we're going to bring it over into the router, and then we're going to reboot the router by turning the switch back on. Now, this particular router is rebooting. You can see the kind of the CLI rebooting here, and it's going to reboot, and we're going to save those settings so it knows now it has that piece of hardware in it, and we're going to configure that next. And first, before we do that, we're going to basically go to the hardware configuration of this one, and we're going to add the same piece of equipment in, and we're going to turn the power back on, and we're going to wait for it to come back up. And once we do that, you're going to see that we now have 2 serial-based connections to connect to our wider, provider network, but we also have the ability to use IP over serial in this case, right? So we're going to configure what we call a third local area network, right? So what we're going to do is we're going to create a third local area network, and we're going to call it the WAN, right? And we're going to call it 192.168. We had 10.20.30.0. Okay, so our connection between 2 routers is actually considered another local area network. That's how we look at it. We have one local area network, another local area network, and a third local area network. And we're going to configure that with a very special cable called serial DTE cable, which is how we connect to these. When you go outside and you look at the phone lines, when you're in the telephone poles, when you're driving along later today, look up. You'll see all the boxes and all the connections using those lines to communicate over great distances, right? That's all local area networks and buildings that you see in these offices, all connecting to that same system and going halfway around the world to communicate with any other network that they can. All right. So what we're going to do is we're going to connect this router. We're going to use our serial 0 connection, and we're going to connect this special cable to our outside phone system to the other serial connection, right? So now we have local area 1, local area 2, local area 3, but we didn't configure it with the 30.0 configuration yet. So what we do is we go to serial 0 on this network. We're going to make it 192.168.30.1. And this is going to be a 128,000 bit per second line. This is the speed of the line we're going to stay in. We're going to configure it this way, and then configure the other one the same way. Any speed that they give you or they can claim it to be is what you have to put in there, but that's fine. Then we're going to flash the memory again, so it saves it, and we're going to go to the other one, and we're going to go to that serial connector, and we're going to give it the same speed to make sure they can communicate properly, but we're going to give it 192.168.30.2. And then we're going to flash that network, memory again. And now what we can do is we can just test the communications between the 2 routers and make sure that we're successful, which we are. All right, now, what this will allow you to do is to send packets between machines, fine. It'll allow you to send packets between the machines and its own router, fine. It'll even let you send packets between the machine and the other router, right? We get fail. Let's try one more time, because actually, that's a good example. We should fail. That's my mistake. We should fail. And the reason is that the routers haven't been configured with routing tables yet. Whenever you have a system, that system is configured with routing tables. You can go to any different machine, and you can go to route print, and it will define your routing tables. Every computer has routing tables that basically tell it how to communicate with the rest of the devices on the network. Usually, it pulls those routing settings from your router. So your router is considered the default gateway. And the default gateway is the first place any device looks on a network to get those routing settings. So first thing we do is we go into our devices, and we're going to put in our default gateway is going to be 192.168.10.100, which is the router IP address of this network. Now we're going to go into this one. We're going to give it default gateway of 192.168.10.100, right? And now we're going to give this one a default gateway of 192.168.10.100. And here, this is going to be 20.100. So we're going to give these a default gateway of 192.168.20.100. Okay. And we're going to give this a default gateway of 192.168.20.100. And we're going to give this a default gateway of 192.168.20.100. Okay. So those are your default gateway settings for each network to point to its default gateway, which is the router that's here. And if you want to make it simple on yourself, you can basically make this default gateway, and you can make it 192.168.20.100. And you can also call this default gateway, and it's 192.168.20.100. And the mistake I made is this is 10.100. Sorry. Okay, so that's our default gateway for each network, and we've programmed these to talk to that. I'm going to save that since we have so much progress here. And now what we're going to do is this. Now we're going to program each router, and we're going to make sure that packets coming from each network can actually know how to get back through the third network, right? So if I'm over here and I know that I'm 192.168.20.1, 2, and 3 and .100, I just know that I can communicate over here perfectly. But as soon as a packet leaves 192.168.20.1 and travels through its own router, default gateway, and hits this router, nothing on this network knows how to send that packet back. Remember, TCP/IP requires a response to communicate. So the packet gets sent out, it might hit its destination because of the physical connections of the wiring and the network cards, but it doesn't know how to get back to the person that received it. Remember, an IPv4 packet has a source and a destination section, and it knows where it came from, but it doesn't know. It knows where it's going, but it doesn't know how to get back if the routing table doesn't say that. So we need to take this router number 1 here, and we need to tell it that every time a packet comes from this network, send it back to this router through this serial connection. Okay, so we're going to add a static route in the router. And we're going to say, I'll slide this over, you can see it. We're going to say everything coming from 192.168.20.0, anything coming from that network, 255.255.255.0, we're going to send that packet back through the serial connection to the other router, because that's how those two routers communicate together. That's how you talk to New York to LAX, because nothing in your office connects direct to LAX directly. We have to tell it how to route that packet. And we're going to tell it that it's 192.168.30.2, because that's 30.2 on the other side of the serial connection. So I add that in. I'm going to make my settings. I'm going to save them. And now I'm going to tell this router, that anything coming from 192.168.10.0, right, we're going to send it back through 192.168.30.1, right? So this is going to connect these two local area networks over long distances, any distance you need between the serial connection. That's how we're going to send packets, but it needs to be told how to do that. That's what routing is. So now I'm going to basically go and select this router, and I'm going to go to the static routing, and I'm going to tell it that any packet that it receives at all that comes from 192.168.10.0, we're going to send it back 255.255.255.0. We're going to send it back through 192.168.30.1, which is the address of the third local area network, which is the serial network, right? And we're going to add that. And then what we do is we basically save that, so that if we reboot the router or reload the packet tracer diagram or something like that, that's fine. Now, when testing, it's always best to test all your connections kind of one at a time to make sure you know where the issue stops. So what we're really trying to do is we're really trying to send a packet from one machine on this side to one machine on this side, but let's go step by step. Let's send a packet between machines first, right? So our switch is still working. Let's send a packet from a machine to our own router, right? We're all still working on that side. Let's send a packet from this machine to this router. The serial connection is working now, right? Now let's send a packet from this machine to another machine on our router, okay? First time we got failed, but that's okay because it's got to learn the routing. So once we send it for first time, the second time it works, right? So never panic when you don't get a response the very first time you do something. It's learning the routes as it does it. So what we do is we take these routes and we do it a couple of times, right? So once we try it once or twice and it gets there, the routes are always successful after that. All right. So what you've done and what you've seen, what I've done, but what you've seen is that we create a local area network. We create a local area network. Sometimes these have grown up separately. Sometimes one company buys another. Sometimes two companies merge. Sometimes one office is a new office for somebody who works remotely, and you have to step those up. There's all kinds of reasons, but the networks grow up differently, which means that they're not going to be the same IP addressing scheme most of the time. So you have to have some way to just take those two successful networks, maybe thousands of devices on each one individually because of the way they grew up. And then you have to find ways to make them talk to each other. And those are routers. You hook one router up to each network, and then you program those routers to understand that, hey, when packets come from one network or one segment of a network, let me tell you how to get back. And that's what we just did. Okay. So in this interest session, we have a peer-to-peer network set up. We have a local area network set up. We have a local area set up with a router, a second local area set up with a router. Then we have a wide area network set up between those two routers. And that, in its essence, is computer networking. And that's what you do every day for different companies or for different sections of your company in one single company. And understanding how networking works, understanding how IP addressing works, understanding how connecting new devices will lead ultimately to cybersecurity as well. But the core of understanding the networking piece, that alone, without really even being a security expert, that alone and understanding how to do that is a lifelong career in itself, right? The entire world works on networking, computer networking. So being able to set up new networks, network designer or network architect is basically what we've done here in thinking out different IP addressing schemes for different segments of networks and figuring out how they're going to talk. Network architect is a job. Network administrator is a job, right? Network designer is a job. So all these different things in computer networking alone. Now, what I will add in is that the formal process and schooling for computer networking and all that stuff, it could take all different forms, but the certification route is actually pretty well above and beyond any kind of bachelor's degree usually required. Sometimes it's a master's degree as well, but overall, the certifications on the technical side of things, you have CompTIA. CompTIA has Network Plus, their certification. It's also helpful to get the A+, which also talks about software and networking and hardware and that as well. And then you have Cisco as their own certifications called CCNA, or Certified Cisco Network Administrator, or CCNE, Certified Cisco Network Engineer. Either of those two, engineer is much more complex, but either of those two exams that you take and certifications that you get, along with the CompTIA Network Plus certification, it will be a real good indicator to an employer that you are able to do the job and at least come in as a junior network engineer and kind of learn along the way. Okay. With that, I'm going to end the session and I'm going to save the video and upload it, but I'm going to stop the recording now, allow for any questions that may come up. And other than that, I hope you enjoyed the session, and we'll let you know when it's on YouTube, hopefully this week. And if you did miss it, you'll be able to watch that from the beginning. Okay, I'm Dr. Mike Nizik from the ETIC, and I thank you for joining today's interest session.